Greetings everybody once again. Thank you for clicking on this to begin with. Another video, another day. Still on trigonometric ratio. So this is the third lesson on this topic series. So today, looking at the trig identities, the thing we're going to be focusing on here is general multi-step problems involving trigonometry. So compared to the first two lessons, this should be, relatively speaking, a bit easier going, but I've included a bit of a beast of a question for you to discuss in pairs at the end, which actually requires just simple trig, but in many steps. So that needs a bit of thinking, and hopefully you'll enjoy trying to solve that one. So to kick off, as ever, for some warm-up questions. Here they are, questions 1 to 4. So pause the video now and try these on your own. And then when you're ready, if you could play the video and check your answers versus my own, just to make sure you're on the right lines, that'd be great. So let's have a look together at question 1. So question 1, we've got this triangle ABC. The sides are labelled, we know every single side, and we want to calculate the size of the angle BAC. And so BAC is this one up here. I've actually forgot to include the A. That's slightly silly, but there we go. And so A is up here, and angle BAC is the angle at A. So for this one, bearing in mind we've been doing the sine and cosine rule, you might know now that actually this is a question where we can use the cosine rule. So just to remind you what the cosine rule is, it's a squared equals b squared plus c squared minus 2 lots of b, c, cos A. So we can apply this now to this triangle. So what I want to do first of all is just to label the sides and angles according to A, B and C. When you get experienced enough and comfortable enough using the cosine rule, you don't need to do this. But if you want to, it just makes it a bit safer, if you like. And so opposite to angle A, this will be side A. Opposite to angle B here, that's going to be side B over on this side. And angle C here, opposite to that one, this 12 is going to be C. However, we want the size of the angle. So we need to rearrange this now, first in terms of cos A, and then we can do cos minus 1 of that to work out what A actually will be. So if we just rearrange this now first of all, we get that cos at A, if we add 2bc cos A to both sides, this side over here would just be b squared plus c squared. We can then subtract a squared from both sides, and then divide through by 2bc. That's skipping a few steps by doing this. If you want to do it step by step, be my guest, but you should arrive at this, which hopefully you'll be comfortable seeing. So once you've got this, we can just do inverse cos of this. So A is going to be cos minus 1 of what we have here. And so b squared, b is 10, plus c squared. Our c is 12, so we plus 12 squared, minus off the side squared, which is opposite to the angle you're trying to find. So we're going to minus off 15 squared. We're going to divide by 2 times 10 times 12. So let the calculator do the hard work now. So shift cos minus 1, 10 squared plus 12 squared minus 15 squared, all over 2 times 10 times 12, close brackets, gives us an answer of 3 sig figs, or 1 decimal place. Same thing in this case. It's going to be 85.5, because next to the 4 is a 5, so this 4 rounds up. So we're going to have 85.5 degrees. And that's question 1 sussed. Let's now have a look at question 2. So question 2, we've got this triangle here, XYZ. we need to work out the length of xz. So xz is the line going from x to z, which is this one here. Now, importantly, what we know are two sides which surround an angle. So if you want to find a side and you know the two sides which surround a known angle, this again is one we can use the cosine rule for. And so if I call this one side A and that angle A, then B and C can go in any order. I'm going to put this as angle B, this is angle C, if this is angle B, this will be side B, if this is angle C, that will be side C. So I'll just again quote the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos A. And we can then just plug in the values. So we want to find A, which is over here. What do we know? Well, B, we know side B is 11.6. And we know side C is 8.7. We also know angle A, so we can highlight angle A if you wanted to. Angle A is 52 degrees. So to work out side A, we just square root all of this. So it's going to be the square root of b squared, so square root of 11.6 squared, plus the square root of c squared, so plus 8.7 squared, minus 2, multiplied by b, which is 11.6, multiplied by c, which is 8.7, multiplied by cos of A, where A is 52, and it's all of that square rooted. So again, I'm on a roll with my colour coding, so I'll just carry on here, just for the hell of it really. So C is 8.7. Again, I must stress it's a good idea to move away from this as soon as you feel comfortable without having to do all this labelling. But this might be a hangover from GCSE. If it makes you feel comfortable doing so, by all means. They can get a bit faster when you don't need to do this. So if and when that time comes, do feel free to not have to follow what I'm doing to the T in terms of this colour coding and highlighting. Some people find it useful, so each to their own. So anyway, again, let the calculator do your hard work here. So just type this in exactly as it appears. So we're going to square root 11.6 squared plus 8.7 squared minus 2 multiplied by 11.6 multiplied by 8.7 multiplied by cos 52. They do take a while to type out sometimes, these. And what we should arrive at here to 3 sig figs is 9.27. So A is 9.27 centimetres. Question 3. This is revision of another topic altogether. This is going back to the binomial expansion from the previous chapter. So we need to find the first three terms in ascending powers of x of the expansion of 3 plus 2x all to the power 5, giving each term in its simplest form. So the first three terms in ascending powers of x, the first term is 5 choose 0, 3 to the power 5, 2x to the power 0. For the next term, instead of 5 choose 0, we're going to have 5 choose 1. Now if you remember the pattern, the power of the first term in the brackets drops by 1, so instead of 3 to the 5, we're going to have 3 to the 4. The power of the second thing in the bracket increases by 1. So next we're going to have 2x to the power 1. And finally, be 5 choose 2, 3 to the power 3, 2x squared. Now I say finally in terms of finally for our required answer, because we just want the first 3 terms, which will be given by simplifying this here. Now the actual expansion would carry on all the way down to x to the 5 terms. But these are the first 3 terms, which is all we need to do. So there's no point in carrying on if we're not given any more credit for doing so. This first one, any integer choose 0 will always be 1. Similarly, 2x to the 0 again will be 1, so we're just going to have here 3 to the power 5. So 3 to the power 5 is 243. The next one, 5 choose 1, so here we press 5 and shift NCR, shift divide symbol, 1 multiplied by 3 to the power 4, and then just multiplied by 2, because 2 to the power 1 is just 2. So that gives us 810. So the coefficient of x is 810. And finally, we'll have the coefficient of x squared over here. So that's going to be 5 choose 2, 3 to the power 3, and then 2 squared is going to be 4. That gives us 1080. And that's the required solution. Those are the first 3 terms in ascending powers of x increasing. X to the 0, non-existent, x to the 1, x to the 2. Finally, for the warm-up, question 4, a brief circle question here. So a circle C has centre M, which is at 6, 4, and radius 3. Write down the equation of a circle in the below form. So this is a trivial question. It's just a test, a little mental nudge to remind you of how the centre of the circle and the radius relate to the equation of the circle. So what you need to remember is the x-coordinate of the centre relates to this a here, minus the a. The y-coordinate of the centre relates to this b, and the radius is this value here, which then gets squared. So for example, if this was a minus 6, we'd have x minus minus 6, we'd have x plus 6 in this first bracket. So the equation of a circle is just x minus 6 squared plus y minus 4 squared equals 3 squared. So now we can move on to the lesson proper. So, area of a triangle. So no prizes for knowing this from GCSE. You should already know from GCSE that for a right-angled triangle with base B and height h, that the area of it can be found using the formula area equals 1/2 BH. The area is 1/2 multiplied by the base multiplied by the perpendicular height. So that works for some triangles only. The formula, like I'm saying, it only works for triangles where the angle between B and H is 90 degrees. That's why sometimes textbooks and teachers will say it's the perpendicular height. In other words, it's the height which is measured at 90 degrees to B. And so this works if you know what the perpendicular height is. So we can, however, derive and use a formula for the area of a triangle that relates two sides and the angle between them for any size of angle. So this is going to be useful if you're not sure what the perpendicular height is, or you can't quite make a 90-degree angle based on the information you're given. So this formula I'm going to derive now with you, it's essentially a generalization of A equals 1/2 BH that works for any angle much in a similar way as we've seen that the cosine rule is the extended form of Pythagoras. So, like it says here, the result is very easy to prove. I'm going to show you how to prove it in these next few steps. This is the result we are aiming to prove. This is the formula for the area of a triangle for any angle C, and A and B are the two sides in any order that surround the angle C. So, how we're going to prove this? First of all, we're going to start off by having a sketch of the triangle. So, here we've got ABC. So what we're going to do first of all is think about how we can actually find a perpendicular line somewhere on this. So, step one, what we're going to do to find our perpendicular, we're going to drop a perpendicular down from angle A to side A below. So what we're going to do there is split this big triangle into two separate ones. So with a ruler, we're just going to do something like this. Going to drop down a line here. This is a right angle, so I'm just denoting this for this is definitely 90 degrees with no uncertainty. And then what we're going to do is label this blue line, this perpendicular we've just created. We're going to label this H. So just write down H next to the line you've made. So that's step one, fairly straightforward. The next thing, step two, we're going to consider the triangle on the right, this one over here. We need to think about expressing H in terms of side B and angle C using basic right-angled trigonometry. So I'm just going to highlight this triangle here, just so you know which one we're using. So this one here in yellow. So just think about how we can relate H and this angle and side B. So if we're talking about H and B, relative to angle C, we're talking about the opposite side and the hypotenuse. If we've got a right-angled triangle and are interested in the opposite and hypotenuse, this is going to be the sine function. In other words, the sine of C is going to be H over B. This can now be rearranged to make H the subject by multiplying through by B, so therefore H is going to be B sine C. So step three, we're going to apply the formula for the area of a right-angled triangle to this triangle ABC. So just to remind you, obviously, area is half times base times height, but this time our base is going to be A, running along, and the perpendicular height is H. So I'm just going to put it into this nice salmon-coloured box, or pink if you'd prefer. So the area of the triangle ABC. Just to start from the basics, first principles, it's going to be half times base times height. So, in our case, it's going to be half multiplied by the base, which is A, multiplied by the height, which we just called H here. But what is H? Just think about what H actually is. We can see here from before that H is actually the same as B sine C. And so I just substitute B sine C in terms of H. This will give us the result we need. So we have half A multiplied by H, which is B sine C. Therefore, in other words, the area of this triangle, or in fact any triangle, is half AB sine C. And that does it. So, let's have a look at some worked examples where we need to use this formula. So the first worked example really couldn't be easier. This is so easy, I would well imagine this isn't going to be found on an A-level paper. But still, it's a good test to know that you can actually apply the formula and know how to use it. So we've got this triangle here. AB is 8, BC is 5, angle ABC is 130. Calculate the area of triangle ABC. So the area is just going to be half. Now we're going to multiply the two sides that surround the angle you know. So the two sides surrounding this 130 are 8 and 5. So in any order, it's half times one side multiplied by the other, then multiplied by the sine of the angle in between the sides you know here. So in between 8 and 5, it's 130. That's all it is. You could label it A, B, C if you really wanted to, but you don't need to. So all we need to do now is just to type this in on a calculator. So half, 0.5 may have been quicker to type, but never mind, times 8 times 5 times sine of 130, close brackets. You should get 15.3 for that one. And if you haven't, just double check. It's probably a very simple mistake, but that is as easy as it could ever get. So easy, in fact, like I've said, I don't think you'll be given one of those in the test, unfortunately. But regardless, it doesn't hurt to have this example, just so you know exactly how to use the formula, because you'll need this knowledge to do the next work example. So, work example 2. This is a multi-step one. So, just thinking it through logically, step by step. We've got ABC is an acute angled triangle. This is crucial information. Okay, if you remember from last lesson, the ambiguous case of the sine rule, this is non-ambiguous. We're told here each angle is less than 90 degrees, so no worries there. The area of a triangle is 19 square centimetres. Okay, so before, what we did for work example 1 is we found the area. Work example 2, we're given the area, we need to work the other way around. So, just taking this here, the area of a triangle, which is half multiplied by 5.4 multiplied by 7.3 multiplied by the sine of the angle in between them. Now the angle in between these is actually the angle B. Okay, so what we're going to be finding here isn't angle ACB. Ultimately, we're trying to find this one here, okay, which is actually this angle in the bottom right, but we can't do that yet. Not enough information currently, which is why it's a multi-step problem. What we're doing first of all is going to work out sine B, where B is this angle here at the top. So, this is the area of a triangle using half AB sine C, and we're told that's equal to 19, so we can just set this equal to 19, and we can then rearrange from there. So, sine B is going to be 19. What I'm going to suggest doing is just dividing through by all of this mess here to get sine B on its own. So divide through by whatever, half multiplied by 5.4 multiplied by 7.3. So divide through the whole thing and see what we get. So 19, just move this to one side so you can see what I'm typing in, divided by a half times 5.4 times 7.3. We get 1900 over 1971. You could give it as a decimal if you wanted to, but because this isn't the final answer, I just suggest leaving it as what the calculator says. So, therefore, angle B is going to be sine minus 1 of this 1900 over 1971 business. The calculator stored that, so we can just do inverse sine, so shift sine, press A and S for the previously stored answer. And we get that it's 74-ish degrees. Now, be as accurate as you possibly can here, because this isn't our final answer. So to avoid any rounding error, what I'd say is, one option, double the number of sig figs you want your final answer to, so give this to at least 6 significant figures, but I think it's easier to remember just to write down the full calculator display. So this one here is 74.5746197. So that's the first step. We've worked out angle B. So now we know what angle B is. Just give that a tick. What else could we work out? Well, we know this angle, and we know the two sides that surround it. So now what we could do is we could actually work out, using the cosine rule, length AC. Okay? So using the cosine rule, I'll just write this down, step 2. Cosine rule for AC. Now I'm not going to write out the cosine rule in its standard form again. I'm going to try and get you to think of what the shortcut way of doing it is. Whatever side you're trying to work out using the cosine rule, okay, it's going to be the square root of, it's going to be a big square root because there's a lot to type in. It's the square root of one side you know squared plus the other side you know squared, then minus 2 lots of the product of the two sides you know, multiplied by the cosine of the angle which is opposite to the side you're wanting to find out. So we've just worked out the angle opposite to AC, which is B, which we did here. So I'm just going to put this as 74.5 ... which just denotes that it is a bit more than this, but I'm not going to write down the whole thing because I've got it here. So the calculator stored in its short-term memory this angle B. So currently the answer is stored in this angle. So that'll make it slightly quicker. So AC is a square root of 5.4 squared plus 7.3 squared, oops, 7.3 squared, minus 2 times 5.4 times 7.3 times cosine of the answer stored in its memory. And that should give you 7.8409 blah blah blah. So that should give you 7.8409 11167 centimeters. So I'm going to label this in the diagram. Obviously I'm not saying you can measure a triangle to within an atom's width, to that number of decimal places, but like I said previously, just write down the whole calculator display to make absolutely 100% sure that you're not going to fall foul of any rounding error, because again, AC isn't our final answer. We're still after ACB. But we can now do ACB because we now have enough information to use the sine rule to find ACB. So the final step is we're going to use the sine rule now to find what ACB is. So I'm just going to section off what's come before. So, sine rule for ACB. So I'm going to just call this angle C. So sine C divided by the side opposite to it, which is 5.4, equals sine B, which is a 74.5 74.57, etc., etc., divided by the side opposite to it, which is 7.84, and so on and so on. So if we multiply through by 5.4, then do inverse sine of that, we can work out what c is. So therefore, c is going to be sine minus 1 of 5.4 multiplied by sine of 54.57, so on and so on, divided by 7.8409, etc. So just be careful you've stored the right values in your calculator, and we're pretty much done here. So what's the calculator storing? So as you can see, the calculator stored the 7.84, etc. So the calculator stored this denominator here, which will save a bit of time and saves us from having to type in every single number. So it minimises, to an extent at least, any manual error from typing in the number incorrectly. So we do shift sine minus 1, press the fraction button, 5.4 sine of b, which is this awkward number here, 74.5746197, divided by this number here, which we've stored in the previous answer. And what have I done wrong here? I need to close a bracket off. So I'm going to leave this mistake in the final edit, because this might happen to you as well. That bracket here needs to be closed off here. Okay, that was an honest mistake. I didn't mean to do that mistake deliberately. I am sometimes that cack-handed, sadly. But anyway, let's just try this again. There we go. So 41.6 degrees to 3 sig figs. So just by adding in that extra bracket, the calculator hasn't exploded, which is good because I don't want to buy another one. 41.6 degrees, brackets to 3SF. So that's a multi-step problem. That's 3 different steps. Step 1 here, step 2, step 3. So on that note, solving triangle problems generally, just to mention about these multi-step problems. Often when problems involving triangles are encountered, the question doesn't make it obvious as to whether to apply sine rule, cosine rule, or the area of a triangle. Indeed, often a question requires the use of various trig formulae, and often the best way to approach such problems is to just work out what you can, and eventually the required solution will drop out eventually. Practice and independent study will ensure you become more efficient at spotting what to do. So on that note, I've got this problem here for you, which I love. I'm going to tell you why I like it so much after the solutions come out, but I've put here paired discussion. So if you can do, I'd suggest to do this in 2s or 3s, just work it through and give yourselves just some affirmation if you're all on the correct page together. See if you can get the final answer to this to 3 significant figures. The only clue I'm going to give you is just write down all the intermediate steps as accurately as possible. Do not prematurely round, because that will throw your final answer off. I'm going to give you no more clues to that, and as I say, I'll tell you why I like this question so much at the end. So have a go at that, pause the video here, see if you can work out BC, this top side. Okay, I'm going to talk it through now. So, I can't do this. Let me know if you found an easier way. The easiest way I found to do this is as a 5-step problem. So for the first step, I would suggest finding BQ via Pythagoras. So BQ is this side here. So BQ is going to be the square root of 5 squared plus 6 squared, which is the square root of 61. 25 plus 36 is the square root of 61. It's okay to leave this in third form. So found BQ, that's root 61. So after each and every step, I'm just going to add this to the triangle as I go. So there, BQ, I wrote in its root 61. Second step, what I'd suggest, is you might want to use basic right-angled trig to find angle ABQ. So if you angle at B, in other words, you might want to find this one here. So relative to this triangle, I know the opposite side, which is 6. I know the adjacent, which is 5. And so I can use tan. So tan of B is the opposite side, which is 6, divided by the adjacent, which is 5. So therefore, the angle at B is going to be inverse tan 6 over 5. Let's work out what that gives us. So shift tan, 6 divided by 5, or tan minus 1 of 1.2. I get 50.1944 2891. And again, I'm writing out all the digits on the calculator to make absolutely sure I don't incur any rounding error. I don't want to lose any points for this question. So I'm going to add this in to the diagram. So put it at angle B. Next, what we can do, now we know these two, and because this is a rectangle, we know this is going to be a 90-degree angle. We can work out the angle at B in triangle PBC. And so what we can do next is work out this angle here, because we know that the yellow bit plus 30 plus this must add up to 90. So this is really straightforward. So PBC must be this right angle, 90 degrees, minus the 30, minus what we just found out here, which was 50.19442891. So use a calculator to do the hard work, as ever. This answer's stored. So 90 minus 30 minus that stored answer gives us 9.80 55. What were the next numbers? 7, 10, 92. 71092 degrees. So again, that can be added into your diagram, like so. Next step. We can find side BP by considering triangle BPQ, the triangle in the middle triangle. So we can use basic trig to work out BP. So BP is the hypotenuse for this triangle BPQ, and root 61, that must be the adjacent, because the opposite side, opposite to the 30, is here. And so if we know the adjacent side and want to know the h, if we're interested in a and h, that's going to be cos. So in other words, cos of 30 is the adjacent side, which is root 61, divided by h, which is BP. So therefore this can be rearranged. So BP is going to equal root 61 divided by cos 30. Let's see what this gives us. So square root of 61 divided by cos 30. And you can actually leave it if you want to as this exact surd, or if you want to, you can just give it as this long number here. So it's 9.018 499506. So again, because we worked out BP, we can add this to the diagram. So now hopefully you can see that now we can actually work out BC. BC is a right-angled triangle, and so because we know a side in that triangle and an angle in that triangle, we can actually work out what BC is. So we know the hypotenuse relative to triangle BCP. BC is the adjacent side. That's the adjacent, that's the opposite. That's the hypotenuse. So if we want to know A, and we know H, AH, that's the cos function yet again. So cos of 9.80 etc. is equal to the adjacent side, which is BC, which is what we want to find, over the hypotenuse, which is 9.0184, and so on and so on. So therefore, BC is going to be this 9.018499506 multiplied by the cos of this horrible looking thing here, so we've got this number stored here. Just double check. Yeah, that's stored. So it's just to multiply this by the cosine of 9.80 55, oops, not 557 1092. And with any luck, you should get an answer to 3 sig figs of 8.89 centimeters. It's easy to just be off slightly, and that would actually have cost you a mark. So, why do I like that question so much? Well, I like it because it's actually very simple. Each step is simple. There was nothing beyond GCSE to do that question. Okay, so why include it in an A-level talk through? Well, I think it's important to know how to just structure things out in a multi-step problem, because just because it's a different qualification isn't to say that these skills of just following things through and without getting muddled, it's not to say that these skills are not just as important now as they ever were. So 8.89, that could have been set on a GCSE paper. That probably would be a grade 9 question, but it's worth knowing how to do them as ever. So I thought I'd throw that in, see how you found that. So, now it's over to you. Just to show you there, 8.89. So, the exercises I want you to do start on page 189, exercise 9e. So try questions 1, A and F, then 5, 7 and 8. With some exam type questions, the ones with a circled E, which are always worth having a look at, whether I suggest them or not actually. Questions 13, 14 and 15. So if you could try those and let me know if you're getting stuck, that would be fantastic. So don't waste any time, set to it now. So thanks for listening, hope you subscribe, and I'll see you in class or on the channel again very soon I hope. Thanks for now and goodbye.